How do noise-canceling headphones work? First, let's find out what they are. In case you haven't noticed, noise-canceling headphones cancel noise. They were originally invented for pilots to help them on long flights, but today people use them recreationally when they're looking for some peace and quiet, working in the office, or just listening to their annoying friend. Prices range from $50 to $300, so it's not super hard to get one. Of course, they don't block out all sound, only low-frequency sounds. What are low-frequency sounds? To start, we need to know that sound travels in a wave, and that every wave has a pattern. If the pattern looks squished, it has a higher frequency and has a higher pitch. If it looks stretched, it has a lower frequency and has a lower pitch. So, noise-canceling headphones only block low-pitched sounds. Higher frequency sounds tend to be more unpredictable and random, so the headphones usually have trouble dealing with them. The headphones silence noise with three parts. First, microphones inside the headphones detect the noise that is passing through, so that they only target sounds that are reaching the inside of the headphones. Then, electronics create a new sound completely out of phase with the original sound wave, making something like a reverse anti-sound. I'll explain this in a second. Speakers then play this so-called anti-sound, canceling both sounds and making it quiet. So, how exactly is this anti-sound created? First of all, sounds canceling each other out is called destructive interference. To understand why this happens, we need to understand the relevance of the superposition principle. Wikipedia says this. Ignoring all that gibberish, all you need to know is that this rule applies to sounds. When we apply this rule, we know that two clashing waves create a new sound wave, one that adds the two waves together, combining their height. The height of the wave represents how loud it is. So basically, according to the superposition principle, combining two sounds will combine their loudness. Now that we know combining waves adds up their loudness, what happens when we combine waves with opposite heights? When two opposite waves interfere, they combine and form a flat line. This flat line represents a height of 0, or silence. Noise-canceling headphones use this trick to cancel their sound. They do this by creating a wave with identical height, but one that's completely out of phase. In order for a wave to be out of phase, it must reach 0, or touch the middle of the line, at the exact same time as another wave, and move in the direction opposite to that wave. Here, you can see that both waves touch the middle line at the exact same time, but both go in different directions. Because of this, both of them are out of phase. Again, headphones create an out-of-phase wave with an identical height, causing destructive interference. This uses the superposition principle and causes both waves to cancel each other out. I hope you found this useful, and I'll catch you in the next one.